Algebras, and welcome to Chapter 1, Lesson 8 Notes. We're almost there at the end. Let's take a look at some word problems in these last two lessons. So we're going to focus in today on consecutive integer word problems. So probably need to know what consecutive integers are, and then just basic number word problems. So that's the real focus today. Consecutive integers. Okay, consecutive is in a row. So consecutive integers are like 1, 2, 3, -3, -5, -7. Consecutive odd integers, odd numbers, right? Consecutive even integers, 2, 4, 6. These are consecutive integers, okay? So when you're talking about just consecutive integers, like right in a row, integers are just the whole numbers, not everything in between. So they're always one apart. So our regular old consecutive integers are one apart. How much does each integer in each group differ? So regular old consecutive integers are adding 1 each time. So if I consider my first consecutive integer to be x, then the next one is x plus 1, and the one after that is x plus 2. So regular old consecutive integers are x, x plus 1, x plus 2, and so on, depending on how many I have. But these odd and even, think about it, 2, 4, 6. How many apart are each of those numbers? 2. Now hold on, before you go and write anything down, odd numbers are also 2 places apart. 1, 3, 5. From 1 to 3 is 2 places. So even though the value you're about to add to your x for these is not an odd number, as long as your x is an odd number, when you add 2 to it, you continue to have an odd number. And same with x plus 4, the next one, if you're doing 3. What if you were asked for 4 integers? X plus 6, ... continuing. So it depends on how many integers you're asked for. X is always that very first integer you have. So as long as that's an integer, meaning a whole number, 0, or all its opposites, then you can very easily get your next ones. Now, what we're saying is no fractions and decimals involved here, okay? I know that you can probably do exercise 1 in your head, but I'm going to show you, using such an easy problem, how you can solve any of these consecutive integer problems. Now, this question was find 3 consecutive integers who add up to 0. Okay, that's pretty easy. It's -1, 0, 1, right? Because -1 plus 1 comes out to 0. And that third one is already 0. So there you have it. So mentally, you can do that and you can get there. Here's how you can go about any of these problems. You always start with naming your variable. Always say x equals your first consecutive, and I'll abbreviate, integer, and I'll abbreviate. How many total do I need? 3. Okay, so your next one is the next number. So x plus 1 equals your second consecutive integer. What I just used are what we call ditto marks, meaning the same thing on this line. We need 3 total. X plus 2 is the third consecutive integer, third and last consecutive integer that I need here. Okay? Let's take those and add them up. Sum is adding. So add them up. So x plus 1 plus x plus 2 is, that's an equal sign, is 0. There you go. Now you combine like terms on the same side of the equal sign. Move any numbers away from the variables. divide if you have multiple variables, and get your answer. 1, 2, 3 x's. 1 plus 2 is 3 for numbers. Bring down your equal sign and your 0. Subtract that 3 over. You get 3x equals negative 3. Well, divide both sides by 3. Opposite of multiplying by 3 is dividing by 3. You get x equals negative 1. Now, I'm not done there because the question asked me to find 3 consecutive integers. So my answer is 3 numbers. What I luckily did is I named what x was from the get-go. And so when I found x right here, I found my first consecutive integer. Now take that x and add 1 to it. What's x plus 1? It's 0. That's my next consecutive integer. Now take that x and add 2. What's negative 1 plus 2? It's 1. There are my 3 answers. And because I already represented what they all were over here, I can just write it out right here. All right? Let's keep going. Find 2 consecutive even integers such that the sum of the smaller number and twice the greater number is 100. Find 2 consecutive even integers. Okay, I need 2. Such that the sum of the smaller number and twice the greater number is 100. Okay, well, I definitely have to start with let statements. X is going to be my first. X equals my first consecutive even integer. Got it. Okay, and I needed 2 total, so now it's even numbers are 2 apart, so x plus 2 equals my second consecutive even integer. Whenever you are finding consecutive integers or consecutive even integers or consecutive odd integers, your let statements always look the same. These are let statements for consecutive integers. These are always what let statements look like for consecutive even or consecutive odd integers. Always. So your let statements are the easy part. Now it's find 2 consecutive even integers, yep, such that the sum, okay, that's adding, of the smaller and, okay, so that's where the sum is, twice the greater is 100. So I'm going to add these 2 things up. It's the sum of the smaller number. Well, which is smaller, x or x plus 2? X is smaller. Plus, because they were summing, twice the greater. Well, x plus 2 is the greater, and I need to twice that whole number. So if I'm twicing that whole thing, it's 2 times x plus 2. Is an equal sign, 100. Okay, now that you've got your equation, it's nice and easy. So we're going to be distributing this to x plus 2x plus 4 equals 100. Combine like terms, so 3x plus 4 equals 100. Subtract that 4. Remember, we have to make sure we get an integer answer. So hopefully this division works out. 100 minus 4 is 96. Opposite of multiplying by 3 is dividing by 3. Got my graphing calculator up here. 96 divided by 3 is 32. So if x equals 32, thankfully I have let statements. So if x equals 32, that's my first consecutive even integer. Now take that and add 2. 32 plus 2 is 34. Now let's just do a quick mental check to make sure those 2 answers satisfy the equation or satisfy the word problem. Find 2 consecutive even integers. We think they're 32 and 34, such that the sum of the smaller, well, 32 is clearly the smaller. So I'm going to check it over here. That's just a little CK in a line, so I know I'm checking right here. And twice the greater. Well, twice the greater is 2 times 34 is 100. So this should be equal to 100. So let's take a peek. 32 plus 2 times 34 is, boom, there we go, 100. Real quick check. Do you have to write that out? No. Do you have to do it? Yes. Just do it in your graphing calculator. That's why it's there. You have that. or you have physically here. One way or another, check to make sure you're getting the answer correct. And again, one of the quick checks is if I didn't get integers, if I got decimals or fractions, I know I'm wrong somewhere. That's a quick check because everything here so far is talking about integers. Okay. The sum of 3 consecutive odd integers is 18 less than 5 times. Whoa, 5 times the middle number. Wow, wow, wow. Okay. Let me try this again. The sum of 3 consecutive odd integers is 18 less than 5 times the middle. Let statements for sure. Consecutive odd integers, and I need 3 of them. So x equals your first consecutive odd integer. The next odd number, you add 2 to get to it. So x plus 2. Notice these let statements are the same as the even. It's your second consecutive odd integer. Now I need 3 total. So the third one is add 4. X plus, because I'm adding another 2 to it, right? Is my third consecutive odd integer. So those let statements are always the same to start. If you read consecutive integer, check for even or odd first, but your consecutive integer let statements always look like these 3 let statements here. They always look like this, or this, or this. And technically these are the same. This one is asking for 3 numbers. This one is asking for 2 numbers. This one is asking for 3 numbers. That's how you know how many to make. Sum of 3 consecutive odd integers is 18 less than 5 times the middle number. Okay. I'm going to start with knowing what the middle number is. And this guy is the middle number. How do I know? It's between these two. Middle. Okay. The sum of these, all 3. So I just list all 3, summing them up, adding them up. The sum of these, got it. That part is done. Is, that's an equal sign. 18 less than. Ooh, less than is a switching word. It means the 18 is going to go second, and this 5 times the middle goes first. 5 times the whole middle number. Each of these binomials, 2 terms, is entirely the number, how we figure it out. So the whole thing needs to be multiplied by 5. Less than, so minus 18. Has to go that order. Subtraction and division have to go in a certain order. They're not commutative. All right, so now we got combined like terms on this side. And this side we distribute. So we got a couple of things going on. So pause it if you need a moment to figure out combining those like terms and distributing. And now over here, I've got like terms. So over here, I got to combine again. 10 minus 18, negative 8. Cool. Let's get all the variables on one side, all the numbers on the other. So I'll get all the variables over here because that'll keep my variable count positive. And I'll get all the numbers over here. 8 plus 16 is 14. Last but certainly not least, divide both sides by 2. I get x equals 7. Now, not done there. My question wanted me to find 3 integers. X is the first consecutive odd integer. Well, we're in luck. 7's an odd number. And if I add 2 to 7, I get 9. And if I add 4 to 7, I get 11. So the sum of these should be the same as 5 times the middle number minus 18. So let's sum them up. 7 plus 9 plus 11 is 27. Okay. So now 5 times the middle number, well, the middle number was 9, minus 18 should also give me 27. And there you have it. So I just checked to make sure there's my answer. Okay? If you don't write let statements, you will not be able to do the rest. So you've got to write those let statements. Okay? You've got to write those let statements. All right, let me keep going. And here I am going to do non-consecutive integers. So I'm going to skip number 4 for the sake of your time. And I'm going to head down here to number 5, exercise number 5. Here it's a little bit funkier because you're not going to have, all the consecutive integers. So it's not going to be always the same let statements. This is going to be, X is going to be what's not being described here, right? So find two numbers whose sum is 20, such that the larger number is 4 less than the smaller. Let's find two numbers. So I'm always going to say that X equals my first number, and I use the hashtag symbol because it means number, pound key, whatever you want to call it. Whose sum is 20? Well, let's think about that. If I need a second number and I know these two things add up to 20, then if I take 20 and subtract X from it, I'm getting my second number. Right? The larger number is, which one is going to be larger? Well, I don't really know. Right? But whichever one I say is larger, 4 less than twice the smaller is the other, right? So let's say X is the larger. The larger number is, X is 4 less than, so 4 comes back here. It's being subtracted from twice the smaller. Oh, I said this was the smaller, so 2 times 20 minus X. Distribute. X equals 40 minus 2X minus 4. Okay, combine like terms on the same side of the equal sign. So 40 minus 4 is 36 minus 2X. Get all the X's on one side of the equal sign. So let's add 2X over here. 3X equals 36. Divide both sides by 3. See what X equals. And let's think about that. X was supposed to be my first number, so I think it's 12. What's 20 minus 12? It's 8. Do these two numbers add up to 20? Yes. Is the larger number 4 less than twice the smaller? Well, the smaller is 8. What's twice that? 16. What's 16 minus 4? It's 12. It is the larger number. So this works out. Okay, and again, check in my head. Make sure. If you don't understand how I set that up, go back, rewind, and watch again. Okay, I need you to remember though that less than is a switching the order word. That means subtract that first number, so put it behind. That's one of the key things that people get wrong in these scenarios. The other key thing that people get wrong in these scenarios is when I say twice and there's two terms that are representing your entire number, you need to twice both. You need to make sure that it's in parentheses in your doubling or tripling or however many you're doing, whatever you're supposed to be multiplying that by. All right, let's try it one more time. And then you guys can work on your homework, which I think is fairly short. Exercise 6, a piece of lumber, which is 54 inches long, is cut into 2 parts such that the larger piece will be 12 more than 5 times the smaller. Whoa. How large are each of the pieces of lumber? Well, I know there's 2 pieces, and I know they are 54 inches long, right? It says right here, 2 parts, and 54 inches long is my total. So if X represents my first number, then 54 minus X will be my second number. All right? Okay, such that the larger part, decide which one you want to be the larger part. Let's say this one's the larger part. 54 minus X is the larger part. Will be, that's an is, that's an equal sign. 12 more than, you don't have to do the switch with addition because addition is commutative. 5 times the smaller. Well, 5 times the smaller part, well, the smaller part is just X. So 5 times X is 5X. So I really didn't have to write those parentheses at all. I was just showing you how I'm considering that even though there's only one term here, considering that all of whatever's here had to be multiplied by 5. Now let's get all the variables on one side and all the numbers on the other. Divide both sides by 6. I get x equals 7. What does that mean? Okay, that means that my first number is 7, and that's supposed to be my smaller number. And 54 minus 7 is my second number, so that would be 54 minus 7 is 47. And oops, I'm so sorry. Let's think about that for a second. This is definitely the smaller, that's definitely the larger, so that's good. 7 plus 47 is 54. The larger part will be 12 more than 5 times the number. Okay. 5 times 7 plus 12 needs to end up being 47. Worked. Okay. Good. You guys got this. You've got to write let statements. You've got to write let statements, okay? You need to before you go about this, okay? Then read, and read again. You notice I was reading everything 3 and 4 times as I'm making my equations. I'm talking it out. I'm making notes to myself about everything. Okay, see, I did that all over the place. Some was a plus sign, and I've got equal signs is, and I'm writing stuff. Okay, I'm making notes. I'm writing my let statements. You need to do the same. I need to see those pieces. You need to understand what your variables are representing. Don't try to just do it in your head and think that'll be acceptable. It won't be. Okay. Come to office hours, ask me questions, make sure you're writing those let statements, read the problem through to make your equations. You guys can do this. It's a short homework. Okay. Go ahead and practice. Watch the video again, rewind certain parts, and I shall be seeing you all soon. Have a great day.